is 2.4, quadratic graphs. So we're going to be finding the turning points of a quadratic, and that is either the minimum point or the maximum point. Now we notice in this example we have A is a positive value, so our graph is going to be a smiling face, and we can see from our graph that our turning point is going to be a minima. So in order to find out the coordinates of this minimum point, we need to complete the square. So the first step is to take the factor out of the first two terms, and then completing the square inside the square brackets, leaving everything outside exactly as it was. So we halve 4 to get 2 and take away 2 squared, which is 4. The next step is to multiply 3 back in front of the two terms inside the square brackets. And the last step is to add the numbers outside at the end. So the idea is that we want this bracket to be 0. The reason why we want it to be 0 is because we're squaring a number. That number squared is always going to be positive, and the smallest we can make a positive number is 0. So we make that 0, and it gives us x equals minus 2. But when it is equal to 0, f of x is minus 7, or y is minus 7. So those are the coordinates of our turning point. Next, we're going to look at values where a is negative. Okay, so this is an example where a is negative. First thing we notice is that a is negative, and so the graph is like a sad face. It's like an upset mouth. And we can see that our turning point is a maxima in this case. So it's a maximum value, excuse me. And it's the same idea, completing the square, to find the coordinates of this maximum value. So out comes the negative 2 this time. So this makes it slightly more difficult. We need to take out a negative number, and we just get x squared. That's straightforward. The next number is a bit more difficult. We have to change the sign so that when we multiply minus 2 by 12, we get positive 24. And we don't change that last term at all. That stays exactly as it is because it's not inside the bracket. Next, we complete the square inside that square bracket. So it will be x minus 6 all squared, subtracting 6 squared, which is 36. We expand our bracket out again using the minus 2. And we add the 72 and the minus 7. Now, we want to make the x minus 6 squared term equal to 0. And so x equals 6. And that is the value, 65, that y takes when the bracket is 0. So we get our coordinates again, this time of a maximum point, but always the coordinates of the turning point are found in this manner. Okay, so if we have completed the square on our quadratic, then it will look like what you see at the top. those, by the way, they're very different values, a, b and c, to how we normally see a quadratic. But if we want to find the turning point, x is always going to be equal to negative b and y is always going to be equal to c. And so our minimum or our maximum point for a quadratic is given by negative b, c. Make sure you take these notes. One of the other things you're going to be asked to do in this part of the chapter is to turn a sketch into an equation. Now we're going to do an example of this on the next slide. However, we're going to do like a quick 1, 2, 3, the steps that you're taking throughout that process before we get started. So the first thing that in your sketch you might get given is what the y-intercept. So if you get given that number, that's going to be c in this equation. It's going to be this number here. And you can immediately, the first step is if you've got the y-intercept, get that into your equation. So write that down with a in it, with a b in it, with x squared, with x, but not with c, with the actual number for c. Step 2, if you have any other points on the curve, you're going to substitute those into that equation. But instead of f of x, you're going to replace that with y. So the normal Cartesian form for the equation. And remember, you've figured out what c is from the sketch already, so you're not writing down the letter c again, you're writing in the actual value. So that's why I've got inverted commas around c. Once you get both of those equations written down, you are going to solve those two equations simultaneously. Okay, that's the 1, 2, 3. That's all we really need in order to get started. We're going to follow these through in an example. Okay, here is our example. The sketch is in the top right of the screen. And first of all, we see minus 12. So we're not messing around with c anymore. Minus 12 goes into that equation. This is what I mean. Look on the screen. Look at where the minus 12 is. C, we leave it behind. Next, we get some pairs of coordinates for the other 2 points. It does just happen that y equals 0 for both of them. So when we substitute x in to our quadratic as minus 4, this is what we get. And y is equal to 0. We do that for our other x-intercept, where x is minus 5 and y is 0. Substituting in 1.5 in for x gives us this equation. I like to rearrange these equations to get them into a form that I like. A number of a plus a number of b equals a constant. On the left-hand side, on the right-hand side, excuse me, I am multiplying by 4 to get rid of these decimals. 0.25 and 0.5 are going to disappear if I times by 4. I rearrange everything so it's in the same form, and you can see them side by side here and here. Now I'm going to make the same number of b's, 12, and I'm going to add my 2 equations so that the b's disappear. If I do that, 48a add 18a gives me 66a, 36 add 96 gives me 132, and I quickly deduce that a is equal to 2. And substituting that into my equation here, using a equals 2, I deduce that b is equal to 5. And my final step is to write down the full quadratic with a, b, and c, as I have just found.